So here's an example of a right triangle problem that we can do using this relationship of 45, 45, 90 right triangles, or isosceles right triangles. Now, before I go any further, I just want to say, in a problem like this, right, where you feel like you aren't given a ton of information, there's going to be, with triangles in general, okay, when we're solving problems for triangles, or if we're solving triangles and trying to get all these sides and angles, okay, all of the information that you need is not going to be shown or explicitly stated in the problem. There are going to be times where you have to look at this and be like, oh, well, that means this. And then you use that information to help you solve the problem, right? So at first glance, when you look at this, if I wanted to know what this side length was and what this side length was, okay, and you look at that and you say, well, I don't know any other piece of information besides this 90-degree angle. Well, you do know that these two sides are congruent, and if those two sides are congruent, that means these two angles have to be congruent. And if those two angles are congruent plus this 90 degrees, you could take 180 minus 90, right? Minus this angle, and take this 90 degrees and split it into two congruent angles, which would both be 45 degrees. So I don't want you to be robots about this thing, right? We want to be problem solvers. So always understand, there's usually in these triangle problems, there's way more than just one way to do it. So if we call this a 45-degree angle and you want to know this side, there's nothing stopping you from saying, oh, if I want to know this side and I call this X and I have this side, which is the hypotenuse, you could do the sine of 45 degrees is equal to the opposite side over the hypotenuse, right? The only thing here is you're going to get a decimal approximation if you do this, okay? If you want to get the exact right answer, we're going to use the properties of special right triangles, okay? So as I've stated in previous videos, my advice when you recognize a special right triangle is label the side lengths how we've labeled our model over here. The two congruent legs are both x, and the hypotenuse is x radical 2, okay? And what that means is the length in this triangle that I'm saying is 7 is equal to the length of the leg times radical 2. Now solve this equation, okay? Divide by radical 2 on both sides. So we get x equals 7 over radical 2. And then we would have to rationalize our denominator like so, and end up with 7 radical 2 over 2. And this would be the side lengths for x that I had labeled up here. Okay, so don't put yourself in a corner. There's lots of ways to do these problems. Just understand that there's usually information that you need to deduce from what's been told to you to start to label this and figure out a little bit more. All right, don't be a robot.